Welcome to This Explainer. Today, we're going to demystify the daunting but absolutely thrilling journey of becoming an independent neuroscientist. Whether you're a high school student mapping out your future, an undergrad looking for your niche, or, a parent trying to understand this wild path, you're exactly in the right place. We'll break down the whole shebang from high school prerequisites all the way to your PhD. We'll look at top colleges in India, map out the global options, and, crucially, look at what this career actually pays.
But before we get into colleges, exams, and salaries, I want you to ask yourself a really foundational question. Are you ready to unlock the secrets of the mind? Do you genuinely have that innate scientific thrill required to untangle the deepest mysteries of the human brain? Because let's be real, this isn't just a 9-to-5 job. It's a lifelong pursuit of understanding how we think, how we feel, and how we literally exist. If that fires you up, well, you've got the perfect mindset to begin.
Here is how we're breaking it down today. First, decoding the neuroscientist. Second, your academic roadmap. Third, skills and top institutes. And finally, careers, salaries, and the future.
All right, let's jump straight into Section 1, Decoding the Neuroscientist.
So what exactly is this job? At its core, a neuroscientist is a professional who studies the structure, function, and disorders of the nervous system. But just look at that scope for a second. You're going from microscopic molecules and cells all the way up to complex human behavior and cognition. You aren't just looking at tissue in a petri dish, you're studying the very machinery of consciousness. Understanding this incredibly vast scope early on is absolutely crucial, because it really dictates how you should plan your studies moving forward.
Now, a super common misconception is that neuroscience is just, biology. It really isn't. Today, it's a highly interdisciplinary mix. You've got biology, of course, but there's an equal measure of psychology to understand behavior, right alongside computer science and maths to model neural networks and process massive amounts of brain data. It's like a giant puzzle. If you only like one of these pieces, you might actually struggle a bit. You've got to be ready to embrace the whole mix.
Moving right along to Section 2, your academic roadmap.
Okay, so the crucial point here is this chronological roadmap. It starts back in 12th grade. Ideally, you want a science stream focusing on physics, chemistry, and biology, or even better, PCMB to keep your math skills sharp. From there, you're moving into a 3 to 4 year undergraduate degree. Think a BSc in neuroscience, biology, or biotech, or maybe a BTech in biomedical engineering. Then you specialize. That's a 1 to 2 year postgrad degree like an MSc. Finally, to truly lead your own research, you're looking at a 3 to 5 year doctorate or PhD.
Yeah, you heard me right. You really need to pace yourself for a marathon here. From the moment you graduate high school, it typically takes 8 to 10 years to become a fully independent scientist in this field. I know, it sounds like forever, but it's a long game, and you just need to be mentally prepared for that timeline from day one.
To successfully navigate that decade without burning out, we can break it down into these 6 essential steps. After you nail your high school foundation and your college deep dive, pay really close attention to Step 3, getting hands-on research experience during your undergrad. This is exactly where you find out if you actually enjoy being in a lab. Then, as you hit grad school, you specialize, hunt down your specific research niche, and finally start publishing papers and presenting at conferences to share your discoveries with the world.
Of course, knowing what test to actually take is half the battle. Keep these different entrance routes in mind. For undergrads, it's often merit-based, but engineering paths might require exams like JEE or GATE. For postgrad, you're looking at university entrance tests. Now, if you're coming from a medical background, say you want to do clinical neuroscience, you'll be looking at MD or DM residencies. And for a doctorate, you'll need to clear institute-specific PhD admissions and interviews.
All right, on to Section 3, skills and top institutes. Notice the careful balance here. You've got hard technical skills on one side and absolutely vital soft skills on the other. Sure, you need to know how to run an electrophysiology rig, look through a microscope, and navigate neuroimaging tools. But listen, critical thinking, scientific writing, communication, and teamwork, those are just as important. Seriously. If you make an amazing, earth-shattering discovery but can't write a paper or explain it to your team, your research kind of hits a dead end. You've got to be a well-rounded communicator.
Actually, scratch that. I want to pause on this for a second because it's just that important. If you want a massive head start over your peers, take this pro tip to heart right now. Learn basic Python, along with data analysis libraries like NumPy and Pandas. The modern neuroscientist deals with literal gigabytes of neural data every single day. Knowing how to code your own analysis, that'll make you an incredibly valuable asset in literally any lab.
So, when it's finally time to apply for those advanced degrees, these are the heavyweights you want to aim for. In India, target top-ranked research centers like NIMHANS in Bengaluru, the National Brain Research Center in Gurugram, ISC, AIIMS in New Delhi, and TIEF-FR in Mumbai. Getting into one of these programs is a total game changer. It gives you access to world-class labs and just incredible faculty mentorship. My advice? Always check their specific admission pages way early so you know exactly what they're looking for.
Finally, let's wrap up with Section 4, Careers, Salaries, and Future.
Now, you might be thinking you're stuck in a university lab forever as an academic researcher. You're not. You can branch out into clinical roles if you have a medical degree. You could become a neuroengineer building real-life brain-computer interfaces. Or you can work in the highly lucrative pharma and biotech industries. You can even pivot, become a specialized data scientist or a science communicator. The skill set you're building here is highly, highly transferable.
All right, let's talk numbers. As a fresher or research assistant in India, you're looking at roughly 4 to 6 lakhs per annum. As you gain experience and move into mid-level scientist roles or jump over to industry, that bumps up to between 8 and 15 lakhs. And as a senior scientist or full professor, you're looking at 15 lakhs and upwards. Though keep in mind, this varies pretty widely depending on your institution and the grant funding you manage to secure.
Let's compare ecosystems for a second. India's research scene is growing rapidly, which is awesome, and there's increasing international mobility through collaborative projects. But looking globally, at the US, Europe, or Australia, those markets can offer notably higher starting salaries. For instance, postdoc or industry roles abroad commonly start in the tens of thousands of US dollars per year. The beauty of this is that it's a totally global field, giving you the flexibility to go wherever the research and the funding takes you.
Looking ahead, the scope for the coming decades is honestly massive. If you align your skills with fast-growing interdisciplinary areas, think neuro-AI, brain-computer interfaces, precision neuropharmacology, or cognitive enhancement, you are going to be at the absolute frontier of human innovation. We are literally talking about connecting minds to machines and curing neurodegenerative diseases. It's sci-fi stuff becoming reality.
I want to take a quick aside for any parents tuning into this explainer. Please remember this vital piece of advice. Balance is key. This is a really long, incredibly demanding path. Support your child's mental health through the inevitable academic setbacks, normalize rerouting if they decide to pivot to tech or policy later on, prioritize their sustained curiosity over forcing them into some early rigid specialization. Let them explore, you know?
And for the students, to make sure you stand out to those top institutes we talked about earlier, seriously, take a screenshot of this application checklist. Start ticking these boxes during your undergrad. Hunt down research internships, even unpaid voluntary ones. Try to get your name on a poster or an abstract. Keep grinding on those coding skills. Try to attend specialized drummer schools. And most importantly, build genuine relationships with your professors to secure strong letters of recommendation.
Well, we've covered the timeline, the skills, the colleges, and the future. A journey of 8 to 10 years is undeniably long, but the impact you can have on humanity, it's profound. You've got the roadmap in front of you now. So the only question left is, what part of the brain's mysteries will you choose to solve? Will you be the one to build the future of medicine, AI, and brain tech? Think about it. Thanks for joining me on this explainer, and keep that curiosity alive.